Hey everyone. I'm sure you are really just missing my voice about right now, so I figured it was time. I know you're rolling your eyes at me. But I wanted to go over the Nearpod, the Introduction to Probability work that you did last week. You kind of had the introduction notes. Some was probably review, some could have been new, but I want to make sure that you have the correct answers to the 6 questions. I saw the results. Not everyone is on the same page. So, in light of me not getting to see you face to face in the classroom, I'm just going to provide feedback from what I saw for the majority of students. So, the beginning of this unit really talks about probability and how it relates to Venn diagrams. So, if you look at number one, the Venn diagram, when it says there's 30 students, the first thing you always want to do is make sure that the numbers add up because eventually you might be making your own Venn diagram. So if you'll notice, there are 20 um, students that are not in choir, nor are they in band. And then we have 10 represented inside of our circles. So that's the first thing I'd like you to look at. So we have 7 that are in choir because 5 plus 2 is 7. We have 3 plus 2, 5 are in the band, and then 2 are in both. So this is where we call the overlap. So it says a student is chosen at random from the class. We want to find the probability that the student is not in the band. So what we're going to do is we're going to take a look at creating this probability as a fraction. When you were younger, you may have done percents, but really in high school probability, we're going to write it as a fraction. So what we're going to do is our denominator is going to be the students that were in the class, so that's 30. And then our numerator has to be not in the band. So if we take the 20 that are not in the band, and then the 5, we would have 25 out of 30. And then we need to reduce this. So if I divide the top and bottom by 5, that would give you a final answer of 5, 6. So we're now going to go on to the second question, which has the same information, but now we're looking for the probability that the student is not in the choir nor in the band. So on Nearpod, I got some funky answers. So let's make sure you know what's going on. So once again, our denominator is going to be out of 30 because that's how many students we have total that were surveyed or in the class. And now we're looking for they cannot be in the choir. So we can't use the 3. Oh, just kidding. We can't use the 5. And we can't use the 2 because they're in the choir and in the band. And then they can't be in the band, so we can't use that. So the only students that we can use in our numerator is 20. So therefore, your final answer would be 2/3. Okay, so I hope those two, it makes a little bit more sense. All right, so now we're going to go on, and this time the questions are talking about a card selection. So in Canvas, I know some of you are like, why is she letting me know that there's 52 cards in a deck? But believe it or not, I've had students in the past that have never played cards. So that's something that you probably just would not know. So here we have 52 cards. And out of those 52 cards, we need to make sure, get to the right place, we need to make sure that you're looking at, this is an and question. And what I mean when I say that is we are looking for the probability of drawing a card that is an ace and a diamond. So it has to fit both of those criteria. So it has to fall in the overlap. So this is called an intersection problem. And obviously that's where the two circles intersect. So our denominator, once again, would be 52. And out of those 52 cards, we only have 1. So your final answer there should have been 1 out of 52. All right, so let's go on to the fourth question that was on Nearpod. And with that fourth question, it was the same situation, but this time it was a union problem. And what I mean when I say union is that it's an or. So out of our 52 cards that we have in the deck, you can draw either an ace or it can be a diamond. Well, we know that we have four. So right here represents the four aces, and we have 13 diamonds. But I can't count that one twice. So we would have 12, 1, and 3. And that would give us 16. So there are 16 cards in the deck that are either an ace or they are a diamond. And remember, you can't count this more than once. So to reduce our fraction, I'm going to divide the top and bottom by 4, and that would give me a final answer of 4/13. The next example, same, we're still using the deck of cards, and this time it says find the probability of a apostrophe, or what you kind of when we call that a prime. And if you remember in the notes, and you might not because it might be new, this is called the complement of a, which means not a. So what this really is saying is find the probability of drawing a card that is not an ace. So we are looking for something, come on pen, that is not an ace. So if you look at your Venn diagram, out of our 52 cards, we don't want the ace, which means we can't use any of those numbers. Now, be careful, you just don't want to use the 12. So yes, 12 of the cards that are not an ace are 12 diamonds, but remember, you have other suits. You have your hearts and so on. So when you add the 36 and 12, that gives us 48 out of 52. So now I'm going to reduce that. I think 4 goes into both. So it would reduce to 12/13, and that would be our final answer. So just remember that apostrophe means not. So pretty much anything as long as it's not an ace. All right, let's erase this and let's do the last one. And then really, you're not moving on this week. I could tell from the Nearpod that some of you just aren't there, and that's perfectly fine. This is strange for all of us anyways. So we're really going to stick with this Venn diagram stuff and make sure you have it before we move on. So our last question, hopefully now with me kind of walking you through this, we still have our denominator in this case to be 52. And this time, if you're confused by what that meant, that is saying find the probability that you're going to draw something that is not an ace, and it can be a diamond. So this and, remember, is like kind of like an intersection. Now, I don't mean necessarily the intersection here, but we're looking for a card that is not an ace. So we can't use the 4 aces again, but this time we're not going to include all of that because it has to be a diamond. So the only number we can use is 12. So there are 12 cards in a deck that are diamonds but not an ace. And so now when I divide both the top and bottom, let's see, by 4, I get 12 divided by 4 is 3, and 52 divided by 4 is 13. So hopefully you put those in your pod correctly, and hopefully this helps a little bit. So the next part you'll do is you're going to be doing a quizzes to kind of make sure, and that way you can immediately tell whether your answers are right. And then you'll do an assignment still just on this concept of probability and Venn diagrams. All right, I hope this helps y'all.